Good day. This is a discussion about the lab that your in-class classmates did this Thursday. A very confusing lab, but what we're trying to do from this is we're using this for stoichiometry. So this is in your lab manual. You can see experiment 7b. So we're taking a reaction, this reaction here, magnesium, with hydrochloric acid, and it's going to generate MgCl2, which we don't really care about, but we're interested in the hydrogen. So what we have to do is we have to establish which is our limiting reactant, the magnesium or the hydrochloric acid, so there's some good practice there. And then we have to get an actual yield of the hydrogen from the experiment, and then once we've determined the limiting reactant, we have to calculate a theoretical yield of what we should have got for the hydrogen if things had gone perfectly. And using those two values, we can take the actual yield, divide by the theoretical yield, and come up with a percent yield. So the lab was somewhat confusing. One student would be coiling up magnesium around the tip of a pen and then building a cage out of copper wire. And the other student would load acid, and this is actually going to be graduated cylinders, what we used. And they would load acid at the bottom, and then they'd carefully drizzle water on top. And what they're trying to do is avoid having the acid mixed with the water. The acid's denser than water, so if we just slowly add the water, it should sit on top of the acid. That becomes important in a moment. So here's a close-up of the cage. That's a terrible way to do the cage. It should be wrapping all the way around the magnesium to trap it in there, especially as it gets smaller. And once everything's ready, they would take this, their graduated cylinders, so this is the bottom of the graduated cylinder, ends up on top because we flip it over, and now the acid just drizzles over the magnesium in a cage. And what happens is we produce hydrogen gas. This is a one-hole stopper, and the gas can force the liquid out, and then we can measure the volume. So the data that was supplied by one of the groups that did the lab today was they provided you the length of the magnesium, because it turns out you need the length of the magnesium to get the mass of magnesium. That's a calculation you have to do. And then they also had to get the volume, and they had to get the volume by making sure the level of the gas in this graduated cylinder was at the same level as the water volume in the beaker. So they had a bit of downtime. Once this got going, this slowly fizzed away, making bubbles, making the gas, and maybe 25-30 minutes later, they got their volume and packed it up. And so this is showing you where you're getting the equivalent. So this would all be hydrogen gas with a bit of water vapor in there. That level's matched up to the water. That's how they got their volume. Not easy to read because these plastic graduated cylinders are very difficult to see the lines. And you don't have to worry about these questions that come up later in the lab, but you do have to worry about the ones I provided. And so in the next video, I'm going to talk about how to do the calculations. And even with the videos, it may not make it clear, but it hopefully gets you started, and then you can start sending questions my way. So that's it for the procedure. We're doing this lab, it's molar volume of gas lab, but really we were doing it for stoichiometry.